and how we work with them, why we use them, all that good stuff. So a complex number is anything that has the form a plus bi, where a is the real part of our complex number and b is the imaginary part. If you think back to when we learned about complex numbers in class, we learned that I is equal to the square root of -1. So before now, every time we saw a negative underneath a radical, we were like, impossible, there's an error, there's no solution. But now we've opened up the world of imaginary solutions. So if we have I squared, it's basically saying that it's the square of the square root of -1. We know the square and the square root cancel out, so I squared is equal to 1. That is an important thing for us to remember because we're always going to want to convert that when we can. So when we add or subtract complex numbers or even multiply them, we want to think about using them as like terms, right? Adding i's and i's, adding real numbers and real numbers. So for this one, we have 2 plus 6i minus 5 plus 3i. So whenever there's a minus, we remember there's kind of an imaginary -1 there that we want to distribute. So I'm going to write my first parentheses without any changes because nothing was changed. But then when I write the terms from the second parentheses, I'm going to want to switch their sign, or it's like I distributed a -1. So -1 times 5 is -5. -1 times 3i be -3i. And then I'm looking for my like terms here. I say that 2 and -5 are like terms. So 2 minus 5 is -3. And then 6i and -3i are like terms. So it gives me positive 3i. And we want to make sure that our real part is in front and our imaginary part is in the second position. So we are all good to go because we don't have to switch anything around here. So for the next one, we know that there's some multiplication happening here. So I'm going to distribute this 5i to everything inside the parentheses. So 5i times 4 would be 20i, and 5i times 6i would be positive 30, because 5 times 6 is 30, and then I squared, because I times I is I squared. If we think back to what we know that I squared is, the next thing we need to do is replace that I squared with -1. So my first term doesn't change, but then 30 times -1 gives me -30. And since my real part always needs to come first, I just need to rewrite this for my final answer. So -30 plus 20i. And we are all good. Okay. So looking at our next example, again, we're multiplying here. And so we can kind of take two methods. We can either FOIL or use the box method to multiply. I'm going to show the box method here, but foiling will get you to the same spot. So since I'm multiplying a binomial times a binomial, I know I need two boxes or two columns and two rows. So I have -2 minus I on the top, 4 plus I on the bottom. And I'm going to multiply to get what's in each box. So -2 times 4, -8. -2 times I, -2i. -I times 4, -4i. And -I times 1, or times I, would be -I squared. I see that I have two like terms here that I can combine. So I have a -8 and a -6i, and then a -I squared. We can replace I squared with -1, just like we did before. So a -1 is just a +1. So now I have two other like terms I can combine. I have a -8 and a 1. This gives me -7 minus 6i. Again, I want to make sure the real part is in front, which it is. And we're all good. So for our last example here, we are going to look at number 4. So this one is just like the previous one. We just have to rewrite it. So remember when we square something, it's like we're multiplying it times itself. So here I'm just doing 1 minus 7i times 1 minus 7i. So I still have to use my box to multiply maybe. Or you can FOIL. So 1 times 1 is 1. 1 times negative 7i, negative 7i. Negative 7i times 1, negative 7i. And negative 7i times negative 7i would be positive 49i squared. Again, I see I have two like terms here. So when I write them, I want to combine those. So I have 1 minus 14i plus 49 I squared. When I was trying to get ahead of myself there. But now that we have an I squared, I know that I can replace that with negative 1. So 1 minus 14i minus 49. And then I have two like terms. So negative 48 minus 14i. And let's just double check that the real part is in front, which it is. So there we go. This is a nice overview of the operations that we can do with complex numbers.